Hey students, here's a quick overview of how to use your calculator's data regression features. We're going to be using the example from your textbook on page 244, number 85. Let's talk about clearing out previous numbers that are entered in your calculator. When you go to your Stat and then Edit menu to go into your editor, if there's already values that you don't want there, simply go up to the top of the row, highlight the list number, and press Clear and Enter. If you want to enter data, and we want to enter this data from page 244, I'm putting this on a speed screen here, but you want to enter your X values in L1 and your Y values in L2. You always want to double check too and make sure at the end that the number in parentheses matches on each side. Then if you want to see your scatter plot actually drawn onto your graph, you want to go to Second and then your Y equals key, which will take you into your Stat Plot menu. Right now this plot is turned off, so I want to press Enter, which will turn it on. Press Enter again to highlight on, and then of course double check your type. We want just a simple scatter plot, so we're fine here. Then if we go into Y equals, we're just going to double check that that plot is highlighted, which it is now, so that means it's turned on. So then when I go to my graph, right now I may not be in a window where I can see my data. So we have some zoom presets on your calculator, and that allows you to find a window automatically that centers around all of the data plots, data points in your stat plot. So that's zoom number 9. And then we have 6 values, so we should have 6 dots here. Then if we want to perform our regression, to figure out what curve or what equation fits this data, we want to go back into our stat, but this time we want to go over to our calc menu. And in our calc menu, we're going to go down in all the different reg listings that you see here. We have an LN reg and an EXP reg. In this unit, we could use either one. This particular problem asks for logistic, which is our LN reg. Then you want to make sure you change the X list and the Y list, and you can watch my keys over on the left to see where I'm doing that. It's second function 1 and 2, the blue letters there. Then go down and hit Calculate, and you should see an output of your A plus B ln X. Now if you don't see all 4 of those rows, what you need to do is turn on your diagnostics if you don't see the R squared and the R, because it's important you have those values for comparison between the types of regression. So here we want to go second 0, which is our our catalog menu, and we'll already be in alpha mode, so if you just press D, which is your X to the negative 1 key, and then scroll on down until you get to diagnostic on, press Enter. That'll paste that on your home screen. Press Enter again, and it'll mean that that setting has been set for your calculator. Now you want to go back and double check that, so do second Enter a couple of times to go back in the cut and paste of the commands you've asked your calculator to do, and you'll see the natural log regression done again, and now we have the R squared values and R values. So this should be the regression equation that you have. Notice we have those rounded to 4 places. And we're going to now add this regression equation to our Y equals editor so we can actually see the equation mapped out in the middle of the stat plot. We're going to hit our vars key right next to clear, and we want to actually go over to number 5, which are statistics variables, and over to EQ and pull in our reg EQ, number 1. And what you're going to see there when you press Enter is that that is your regression equation that's stored in your calculator's memory, now plugged into Y1. So now we want to see that graphed, and you can see the curve going right through the data points. Now, if we wanted to verify a problem's solution, so our example possibility problem here is, what is the weight X of an animal if its lowest galloping speed in strides per minute is 150? Now we have 2 values in our table, that is 164.2 and 125.9, but we don't have values in between, so we can guess, of course, that it's somewhere between 75 and 500, but that's giving us, quite a lot of span here. So what we're going to do is we're going to work through this problem algebraically, and you guys know how to solve these steps already. So we're going to plug in our y, which we do know right here, as 150. That's our speed. And we want to find out what is the weight. So if we go ahead and subtract our 256 from both sides, we get negative 106.2439 is equal to, remember to keep that negative there in front of the 20, and then if we divide here in this step, on this part of the equation, we're going to get 5.10665. Remember, we're going rounded to 4 decimal places most of the time with these log equations, so keep an extra decimal place. I've got 5 here, as you can see. And we are saying that that is the approximation for ln of x once ln is by itself. Now remember, ln of x is the same thing as log base e of x, so if we rewrote this last step in exponential form, it would be the base of the log, remember, is the base of the exponent, so it's e to the 5.10665 is approximately equal to x, and when we do that out on our calculator, we get, and round to the nearest tenth, 165.1 pounds. Now that is a more exact value than we could maybe just estimate from the data set that we have before. So what we want to do next is we want to check whether this value is true by using our graphing intersect features. All right, at this point we're going to put our value that we're working with of 150 into a second y equals, into y2 here. That is the galloping speed that we're interested in figuring out where does this intersect with the graph. So once we plug that in, we're going to see a nice horizontal line here at 150, and we're looking for the intersection of the two lines, the curve and the horizontal line. This is in our second trace or calculate menu, and remember intersect is number 5. And it's going to ask you a couple questions. You need to ask what is the first curve. They give you the equation. You can see that's the logarithmic regression, and yes, the second curve is the horizontal line. So we're going to go and backtrack now with our arrow keys over to where we think the intersection is. That's our guess, and press enter. And lo and behold, the intersection value for x is the same as what we came up with algebraically, 165.1.